Hi, welcome back. Well, we're right in the middle of a custom build on an M1 IROC slot car, 1/32nd scale with Dave Dubel. We're here at the Vortex. That's where his track lives, and that's where our workshop will be as we get this build done. And you can see here that Dave is a Ferrari guy, although that's not what we're building today. But there's plenty of red Ferraris here at the Vortex, and so that's one of the great sights and sounds that we have when we're here at the Vortex. But enough talking, let's get busy and continue with our build.
Okay, the next part of this is I want to go ahead and put the pinion gear, which is a brass 13-tooth slotted pinion, onto the end of the motor shaft and get that set up and ready to go and be in the right place to engage the gear out
Is
here.
there any standard on the diameter of these motor shafts?
The motor shafts are 2 millimeter, and on all of this type of Chinese manufactured motor, it's pretty much standard. When you get into the smaller, what they call an FF050 type motor, that's used primarily in polycar and in some scale electrics and Carreras, these little guys have a shaft that's 1.5 millimeters in diameter, and it's the standard for that. These are called toothbrush motors by some folks because they were used in electric toothbrushes. So next we're going to take the gear and the motor and a simple tool and go to the vise and mount that gear. Okay. I have some very expensive gear presses, but this old standard from way back when is just the simplest and nicest thing to use. The other ones are fancy and do all kinds of things. They'll put the gear on while it's in the car and on, but I like this guy because of its simplicity. So we're going to open this up where we can catch the motor shaft on that side. We're going to see if we can hold the pinion against this side.
I'm going to zoom in pretty tight here.
Okay, we want to be sure to mount the gear on the right side of the motor, which is what they call the can side. This is called the motor can. This plastic part where the electrical connections are is called the end bell. So the way this chassis is set up, it's driven off this side of the motor, and so that's the side we put the gear on. And I'm going to estimate how far onto the shaft I'm going to press that gear.
So it's basically a little C-clamp that's customized on both ends.
Yeah, back when there was a company called Parma that made slot cars and parts. They manufactured this. A lot of other companies did too. I bought this, I think, when I was a little kid. But it works, and it's simple and just very quick. So I'm going to run that guy down to where I've got maybe about 1/8 of an inch, maybe not even that much, in between the motor and the gear. Be close. We're going to find out where it's actually going to be as soon as I get back over to the chassis and set it up. So we'll probably come back here. Okay, this is another one of those pre-assembly deals where you've just got to fit things together. Again, the axles fit in there very nicely. You want to put the motor pod in its approximate location in the chassis. And then I like to run these gears with the hub facing out toward the tire. Now, you can't always do that with these things because the chassis protrudes. Okay, I've just done a loose assembly of putting the pod into the chassis, sliding the axle into the pod, and putting the gear on to where it's going to clear the side of the chassis down here. So let's go ahead and take the motor and set it on top of the pod. The only thing I really want to make sure of is that this side of the can is tight up against the pod piece there. It's not snapped into place yet, but that doesn't matter. What I'm looking for is, did I get the gear onto the motor far enough? And as you can see, I hope from that camera angle, I did. It's going to mesh with the spur gear and we're good to go. We can go ahead and install the motor. Putting the motor in is pretty much just pressing it in. It's not always real easy. You want to get the end bell part into the enclosed end of the pod, and then you've got to push that back in there. Once it gets in, snap the motor down into place. That doesn't always work really well. Sometimes you'll see the pod protruding out away from the motor. Good way to fix that is with some pliers. I use these big needle nose and basically just squish that to where the plastic goes up against the side of the motor. You can use something else, but these seem to work okay when I can grab it. There we go. So, motor snapped in place. One thing that we're going to do is we're going to put what's called a motor screw into it. The end of the motor has little holes. There's a little hole provided here in the motor pod, and we're going to anchor that thing in place so it doesn't spin back and forth in the motor pod when you accelerate and decelerate. Okay, we're going to go ahead and install the wheels and tires on the back. We've got the motor in place, we've got the gears meshing real nice, everything's going well. We've got this wheel on there and tightened up. I'm going to throw the other one on there and tighten it up. And basically when you get this to this stage, you want to have a little bit of play so that rear axle assembly will move side to side. And it's
like a piece of paper
like a gum wrapper or something like that. It's you can't see it, you can feel it. There's just a little bit of wiggle, and that's enough. So tighten up the set screw that holds the wheel to the axle, and that's another thing about these versus modern slot cars versus the old school 60s slot cars, is that the wheels are held onto the axle with a set screw, so are the gears. Back in the old days, everything had, the axles were threaded on each end and everything had nuts. You had to place a nut against the chassis to hold the wheel off where it needed to be, and then put a nut on the other side, sometimes double nut things so that they didn't move, sometimes using Loctite, all this other stuff. We've gotten away from that, and I don't mind. It was a lot of work, and they would come loose during the race, so it was kind of tedious. So, okay, earlier I spoke about having to fill this gap between these ribs with O-rings, and what I do is I buy 12 millimeter OD by 9 millimeter ID, 1.5 millimeter thick O-rings, and I buy them in bulk because I wind up using these a lot. So I'm going to put 3 of these guys onto this wheel.
Well, if it's not fiddly, it's not fun.
Right. And so now we've got this on there and fills up the thing, and we're going to take and slip the silicone tire over this. And there we go.
Let me zoom in on that.
Okay, we got a nice silicone tire. These things are generally perfectly round and they stick to our tracks very well. And that's a pretty looking wheel. That's a Staff's brand wheel. I've only used one set of these before, but they make different colors and real nice. So there is basically the assembly of the motor pod, almost complete, and what we're going to do is finish that up real quick and then assemble it against this 3D chassis.
Did you have to do any dressing with this 3D chassis, or sanding or scraping or anything, or is that pretty much the way it comes?
This is pretty much the way it comes. The CG Slot Cars brand of 3D printed products is really well made. I've used several of his chassis, and I also use his tire truing machine. This machine is 3D printed and very, very accurate for truing tires. I even have a couple of his cars where he's printed the bodies, and he just does an immaculate job of creating these things and sending them out. One of the problems that we seem to avoid with 3D printed chassis is the warpage that you get with molded chassis. These companies are there to make money. They're pumping chassis out pretty fast, and so sometimes they'll pull the chassis out of the mold a little earlier than they should, and you wind up with a chassis that could be twisted this way or that. And then there's, once it arrives here, there's a procedure for getting that fixed. But with these guys, it's not a worry at all.
What about durability on this stuff?
Durability is fantastic. The material is very, very strong. This is a nylon-like material and is the most common material that I've seen used for chassis. But if we go back to that tire truing machine, he uses a material that has carbon in it, and I've got a couple of his chassis that have that carbon impregnated into the material that is printed up for these things, and it's strong. It's really strong, and I've never had any trouble with one breaking. I've used 3D chassis from several manufacturers, including 1/24 size from Angelo Amato. He's one of the maybe you want to call him a boutique manufacturer. He doesn't put them out in great quantities, but he puts out some great quality. Anyway, we're going to make sure that everything has a little bit of movement side to side. Once I get that side of the wheel assembled, we're going to tighten this thing up, and then we'll move on to the front end. Okay, so I've taken the motor pod, which is pretty much assembled now, and I've screwed it into the chassis, and that's no big deal. It's easy. We all know how to screw screws. But to give it a little bit of an initial setup, with my experience on these things, what I like to do is I like to, once I get these 4 screws that hold it in place tight, snugly tight, I'll turn the front ones out a half a turn, and I turn the rear ones out about 1 turn. And that's just a baseline. We're going to adjust it from there once we get it on the track and see how this particular group of parts works. But for now, that's just a basic setup, and we're not going to worry about it from here on out. Alright, we're going to assemble the front axle and get this thing to where it'll roll around. Kind of like that. And one of the neat things about this brand of chassis and a lot of the other 3D printed chassis is that you can put these little swivel ball type spherical bushings into the front. There's a little cutout for it down here on the very side, and what we're going to do is we're going to put that over the axle, and we're going to go in sideways with it, turn it a little bit, and slide it all the way up into the front upright. You can just barely see it in there. There's enough clearance where it's going to stay, but it will still slide up and down. Go ahead and install the second one. Do the same thing in reverse order, and move on to the next part. Okay, so now with those installed, what we want to do is we want to install the controlling set screws. The way the chassis is made is that there's a set screw that rides down through the top of this in these two little holes here and pushes against the top of that bushing. On this particular brand, on the bottom of the chassis there's two little holes and screws go through that and up against the axle, and they hold it up. Okay, our next step, once we got the front axle assembled, the tires are on, we're ready to go, what I want to do is to do a very quick demonstration of what the guide flag is going to look like when it's got the braid in it. What I want to demonstrate right now is getting the front end set up to work with the track. Our tracks in this club have steel metal braid that's recessed into a MDF surface, and hope you watched the video of Stan's track build. I was lucky enough to get to help with that, and it was just phenomenal. But a typical setup for us on most of our tracks is 25 thousandths of an inch depth between the electrical contact on the track and the actual track surface that the wheels run on. So I've got a nice little board from TrackMate, or no, this is from ProTrack, and we're going to set this on its braid because the thickness of the braid matters, and then we're going to go ahead and put it onto the chassis. I was going to just put the guide flag on this chassis without any spacers, but as it turns out, in this 25 thousandths depth of the recess, what I need to do to get a good setup on the chassis without the tires interfering with the handling of the front end, it's got a gap down here beneath the chassis where the guide flag fits in. So I am going to need to add some spacers. I like these nylon spacers. They're pretty slick and they don't stick too much. But let's change the camera angle and we'll show those going in.
Because the chassis is already as low as it's going to go, right?
Yeah, the axle is all the way up into the uprights, riding in its bushings. And I want to be able to get a little bit of adjustment out of that. So what I need to do is raise the front of the chassis ever so slightly in order to get that. And let's try and see what this looks like and see if our gap gets filled. And there we go. And the tires are getting a little bit looser on the track, but let's go ahead and add a third spacer on there. It's kind of hard. I've got a bandage on my finger, and it's just one of those unfortunate days for that to happen. And so what do we got here now? Yeah, we've got a little bit of this, and so I can dial, that's too much, I can dial that out as after I put the set screws in to control the axle height. Okay, so again with the adjustments made, body ready to go, the interior is in place. Nothing that we need to do with that. We'll get the wires onto the motor, we'll get the polarity correct, and we'll get our special screws for fixing the body. And the next time you see us, we'll be dialing it into the track. So look for that video to come.
All right, I'm going to let Dave keep working, and we'll see you next time, and we'll get this car tweaked up for racing ready on the track. We'll see you then.